All right, so it's going now. We're on YouTube's. Every optimization problem starts out the same way. They're trying to find a min or a max. So it all comes down to having an equation and doing the first derivative test or the second derivative test. Usually it's up to you, but I mean sometimes they restrict the information you have. So these two problems that we're looking at today, I'm glad we don't have to do those tests. If you're watching at home on YouTube and you don't know how to do the first or second derivative test, come by my room. A great day to stop by would be today after school with the rest of us. But these problems come from, everyone has one already? Great. Yeah, BC test and AB test. Every year there's 6 problems on both tests, and there's always overlap. So they always give you the same problems to get the BC kids. Then they pick one problem, they're like, okay, this one's a little easier, we'll drop that on the AB test, and we'll ask something about sequences and series, and we don't cover an AB on the BC test. But these are questions that I think they were allowed a scientific calculator back when these questions came out. Old school questions, 1982 and 1972. All right. Do you guys want to try 1982 first? Or 72? What do you want to do? Let's do 82. At home, you're reading the question. A tank with a rectangular base and rectangular sides be open at the top. It is to be constructed so that its width is 4 meters and volume is 36 cubic meters. If building the tank costs $10 per square meter for the base and $5 per square meter for the sides, what is the cost of the least expensive tank? Back then they didn't tell you this, but now they will. The volume for a tank, well, for this tank, is a rectangular prism is just going to be length times width times height. You don't need to have that memorized for the AP test, but you should for life. Okay. Do you understand why it's an optimization problem? What's the least expensive tank? Right? Okay, so first step in every optimization problem, just like in our related rates problems, your first step is to write out the equation that means everything to us. So for us on this equation, what means, or for this problem, what means everything? What equation matters? Not really. This one doesn't matter. It's relevant. We're going to use it, but it's not our big focus.
The LL prime and the ABCD prime.
If we took the derivative of this,
Yeah.
sure. But why would we take the derivative of volume?
True.
Are we trying to find out how fast the volume's changing? Does the volume change? Not really. Well, it could if we changed the lengths. What matters to you? So you're a mathematician working for a company, and they say, okay, we want to make the least expensive tank. Here are the parameters: $5 per square meter on the side, $10 per square meter on the bottom. It's got to hold at least, what, 360 cubic meters?
36.
Oh, 36. Oh, that makes it smaller. That's easier. Oh, good. So that means we can even fill this in. That has to equal 36. Not that it matters. It might, but it's not what we care about. What do we care about?
Money.
Money. Amen. So, set up a money equation. What, is that hard? This might take multiple steps. This problem, you'll notice this problem is very different than problems we see now in the AP test. This is one paragraph problem. Nowadays they have like 6 different stages for each problem, or 3 steps, parts A, B, C, and D. And now it's just one big problem. Okay, so we need a money equation. What variable are we running? Is M for money, C for cost?
Money.
M? Money. All right? This is going to be our big focus, because if we can get an equation, then doing the first order test or second order test to find the minimum or maximum, whatever we're looking for, in this case the minimum, then it's easy. The hard part's writing this equation out. Okay, well, how are you going to calculate the total cost of this tank?
Well, length times width would be one of the sides, right?
Yes.
And so then 5 times the length times the width.
5 times the length times the width would be the cost of one side of that tank. Oh, wait, let's draw a picture of a tank, so viewers at home see what you're talking about. All right, so here's the tank. We don't know the length. Do we know the width of the tank?
4 meters.
It has to be 4 meters wide. Okay, so hopefully that'll help some. And the height. So Colby's like, all right, so we can do length times the height, or length times width. Oh wait, length times width. That won't give us the side of the tank. Not the way I drew it, at least.
Okay.
What would length times width give us?
That would be the base.
It would be the base. Now, does it matter which one's which?
Yes.
Yes.
Yes. Why?
That's how much it costs.
Different price.
They have different costs. Right? So it totally matters which one's which. Well, let's go ahead and do the base. That's easy, right? Because the base is going to be just $10 per square meter times, how big is the base?
4L.
4L. Does that make sense?
Mm-hmm.
All right, and we can break this up in like 18 different little steps if that's easier, but if you guys want to dive straight into this equation, it works perfectly just as well. All right, so now we need the cost of the sides. How expensive will the sides be? Well, it's $5 per square meter. I'll do that hard part. All right. How many square meters will the sides be? 4H. 4H is going to be this part times 2 because there's a back side. All right. So
An HL.
4 times 2 times H. Is that all right? Actually, maybe we should do 2 of those 4H sides plus 2 of those. What side? What's the other side?
LH.
LH sides. That is a nasty equation. Okay, so how's that look?
Fine.
Easy to simplify at least. Maybe we'll simplify it a little bit. Maybe that'll help some. And on the AP test, and of course you can do this in any order you want. You don't have to simplify. I'm going to even distribute my 5 because it makes life easier. 2 times 4 is 8, times 5 is 40. All right. Do you see any problems with this? What do you like or not like about it?
Two different variables.
2 variables. How's that make you feel? Sad? Where's our calculus? Oh, here it is. All right, so here is a big hint about the AP test. The calculus book is called Calculus of a Single Variable. So that means everything on the test we need to be able to reduce to a single variable. Welcome on. How? How will we reduce this to a single variable? Where did I put the pages?
By using the volume formula, setting it equal to 1.
Now the volume formula comes into play. All right, so we know that the width has to be 4. So we have 4 times LH has to equal 36. All right, which letter should we solve for, L or H? It really doesn't matter. I mean, L and H are both in 2 terms here. L, okay, so we're going to solve this for L. L is equal to 36 over 4H. There was no right answer. Those at home might try to solve for H just for funsies. And that gives us 9 over H is L. So now we go and we substitute this back into our problem. We get M equals 40 times 9 over H plus 40H plus 10 times 9 over H times H. Oh, H is canceled. Isn't that nice? That's such a happy feeling. Does this make sense? So that's going to be M is 360 over h plus 40h plus 90. Good? We've now taken a monster actually it's not even an equation, a crazy paragraph, translate it into a monster equation, simplify that equation, a little substitution to write a very easy to comprehend equation. Now what? Don't lose sight of the purpose of the problem. What's our goal with the money?
Least expensive.
Least expensive. So what are we looking for?
Critical numbers.
Critical numbers, because we need to minimize this. When does this hit its minimum? Alright, let's take the derivative. Oh, this is such a great problem. I still worry about so many of my students taking the derivative of 360 over h. That shouldn't be a fear of mine, but it is. If we were integrating, it would be. It'd be 360 times the ln of h, but we're not integrating.
Negative 360 over h squared.
Alright.
Oh, negative 360 over h squared. Do we need to decide? A quick timeout. How do we do that? May I erase this part, just in case the viewers at home are like, wait, why is that negative 360? Whenever you see 360 over h, or, well, anything, a fraction like this, if you're taking the derivative, taking a derivative with respect to h, if we're taking a derivative of this, then we want to think of it as 360 h to the negative first. And then that's going to be the negative comes down, we get negative 360 h to the negative second, or negative 360 over h squared. Okay, continue deriving. Derivative of that part is 40, and the 90. So, now what?
Set equals 0.
Set equals 0. This is your favorite part, isn't it?
Yeah.
Once you get your derivative set equals 0, you feel like, all right. You just hold your breath and you cross your fingers and you hope that it's all going to work out pretty. I'm still running out of room. I'm back up here. So negative 360 over h squared plus 40 has to equal 0. So negative 360 over h squared has to equal negative 40. H squared has to equal 9. H equals 3. And now we have to hope something. We have to hope this is a minimum. Now we will check and make sure it's a minimum. But if it's not a minimum, what does that mean? If it's not a minimum, we probably did something wrong. Because to only have one critical number, if it doesn't pop up as a minimum, there aren't really endpoints we can check. So we're in a lot of trouble. On your AP test, if they ever say, find the minimum, if you only get 1 point, you will be right. That will be your minimum. But you cannot assume it's the minimum. Show it's the minimum. So how do you show 3 is the minimum? Test it. First or second derivative, doesn't really matter which. At this point, I don't really want to do a second derivative of this thing. I mean, it's not that bad, but it's still like first derivative is a little easier here. So our critical number's at 3. And we're just testing our first derivative. I just want to know, what is m prime doing for values of h that are, well, less than 3. So let's plug in like 1. When you plug in 1 for h, we get negative 360 over 1 plus 40, negative. Plug in something bigger than 3, like a billion. What's negative 360 over a billion squared? Very small number, pretty much 0. Right? Plus 40, going to be positive. Are we happy with this?
Yes.
Yes. And on the AP test, unfortunately, this doesn't count as proof, which is sad. It's not fair. It's lame. Everyone grading the AP test knows exactly what you're doing when you write this out. Especially if you're like, okay, down and then up, it's a minimum. We win. But they won't count this. So use words. and it's not a lot of words. Just say the slope changes from negative to positive at 3. Therefore, the minimum is at 3. That's plenty of words. When h equals 3. Okay, so now we pretty much have all that we need to have, right? H is 3.
But it says how much it costs.
Yes.
You just plug it in.
L, W, H, I'm trying all our things up here. W they've set for us was 4. H is 3. What does L have to be? I can plug it up here to solve for that. It's going to be 3 also. And I like that Avery reread the question. That's, oh, guys, please, on your AP test, after you get to what you think is the answer, reread the question and make sure you're answering what they're asking. They aren't asking for what should our dimensions be to minimize the cost. They're asking what is the actual minimum cost. So now we actually have to plug these things in to calculate the cost, which is a pain, but not that bad. What would be the easy place to plug them in? We could plug them in here to calculate the cost. That'd be a really easy part.
Or any.
Right? Any of these M's.
Yeah.
The only reason I don't want to use this one, you can,
Use some of the one.
but like there's just so many things to plug in, lots of little math. I like this one because it's only one variable. All I got to do is my whole cost is dependent on what h is, and h is 3. So 360 over 3 is 120 plus another 120 plus 90.
3,000.
Not 3,000. I hope not. But what is it? 300 what? 330?
Oh wow, why did I get? Yeah,
I don't know.
It was 330, but I just put a 0.
I was like 3,000. Whoa.
It's getting a little excited.
So M of 3 is that. My h is 3. Cool. Freaking hard problem? Yeah. Really hard. It's a PC problem. Questions? That was exciting. This is where mathematicians make money in business. You go to a business and they say, we want to make more money. And you say, well, let me see what you're doing. And you look at everything they're doing. You're looking at operating costs. You're looking at sales. You write equations without having them, because no president of a company is going to walk up to you and say, oh, f of x is our sales. It's like, well, then why don't you do it yourself? So as a mathematician, you go there and you kind of look at what information you have. Like in this case, like, okay, every tank has to be 4 meters long or wide because that's what the machine cuts them as. And you're like, okay, cool. You know, that's what you have, and then you develop everything else. And you're like, hey, you know, if we make this tank 6 inches shorter but 6 inches longer, we're going to make a lot more money. And they're like, well, really? You're like, yeah. You make them a few $1 million. They cut you a check for $200,000. Everyone's happy. All right.
Are we going to do the second one as well?
Yeah.
Do you want me to do it in the same video or a separate one?
Oh, it doesn't matter. What do you want to do?
For rendering.
We'll cut it. Cut!